In our previous lesson, you have seen how to differentiate a function from the first principle. Today, we are going to be talking about differentiation using product rule. If you are new here, kindly subscribe to my channel. Press the bell icon so that you will be notified whenever I upload a new content. If y equals u times v, where uv are function of x, dy dx will be equal to, keep u constant, differentiate v, dv over dx plus, keep v constant, then now differentiate u, du over dx. You can write this one right before this because addition is commutative. And this formula for product rule is being derived from the first principle too. If time permits, I'll show you how to prove this. Suppose y equals 2x minus 4 times x squared plus 2x. There are two ways in which you can differentiate this function. First, you can expand the bracket, and secondly, you can apply this rule, which says that you can let this to be u while this to be v. If u equals 2x minus 4, then du over dx will be equal to, you differentiate these algebraic terms, starting with the first one, which is the first term is 2. If you differentiate it, minus 0 because the derivative of a constant term is 0. Then v equals x squared 2x. dv over dx will be equal to, if you differentiate this term, you will have 2x plus, if you differentiate the other term, you are going to have only 2. Now let us substitute into this formula. From here, dy over dx will be equal to u, and now u is 2x minus 4. 2x minus 4. dv over dx is 2x plus 2. 2x plus 2. Then plus v. V is x squared plus 2x. X squared plus 2x times du over dx, which is 2. Now let us expand each of these brackets. This time this is 4x squared. This time this is 4x. Minus 4 times 2x is minus 8x. Minus 4 times 2 is minus 8. Then plus x squared times 2 is 2x squared plus 2x times 2 is 4x. Now let us collect the like terms together. 4x squared plus 2x squared is 6x squared. 4x minus 8x is minus 4x. Then minus 4x plus 4x is 0. Then minus 8. Therefore, dy over dx is equal to 6x squared minus 8. Suppose y equals to x squared times 2x. If this is what you have, first of all, if you like, you can expand this bracket. You know y will be equal to this times this, 2x cubed. Then dy over dx will be equal to 2. Then you differentiate the function x. You times the x by the exponent, which is 3x. Then you subtract 1 from the exponent, 2. Then this will be equal to 6x power 2. Now let's apply product rule and see. Let u equals to x power 2 du over dx will be equal to 2x. Let v be equal to 2x. dv over dx will be equal to 2. Now using the rule which says the y over dx is equal to u, then dv over dx plus v du over dx. This will give us, you know that u is x squared, dv over dx is 2, then plus v, and you know v is 2x, du over dx is 2x. X squared times 2 will give us 2x squared plus 2x times 2x is 4x squared. This altogether equal to 6x squared. Therefore, dy over dx is equal to 6x squared, which is just equivalent to this. So where do we derive this formula from? If y, which is a function of x, is equal to u times v, u and v are functions of x, dy will be equal to f of x plus dx minus f of x. dy will be equal to, since u is a function of x, you say what? U plus du, the other term v plus dv minus f of x, and f of x is uv. If you expand this times u times v is uv, u times dv is u dv. Then the other term, du times v is v du plus du times dv, du dv, then minus uv. We have uv here, which is positive, and we have another uv which is negative, so they cancel out. Dy will be equal to u dv plus v du plus du dv. Now we are going to divide each of these terms by dx. Therefore, dy over dx will be equals to u dv over dx plus v du over dx plus du dv all over dx. dy over dx, as the limit of du dv approaches 0, limit du dv approaches 0 will be equals to u dv over dx plus v du over dx plus 0, because if du times dv is equal to 0, divided by dx will be 0. So in a nutshell, this is what we have: u dv over dx plus v du over dx if the function are in product form.